In this lesson, we're going to be solving one-step equations using multiplication and division. Remember, our goal when solving an equation is to get the variable by itself. To do that, we are going to use the inverse or the opposite operation. Yesterday, all of our equations were addition and subtraction equations. To solve an addition equation, you had to subtract. And to solve a subtraction equation, you had to add. You're going to find the same thing today when we work through multiplication and division equations. Let's start with a multiplication equation. Let's say I have the equation 4x equals 28. Now we know this is a multiplication equation because the 4 is multiplied to the x. So what we need to do to solve this is do the inverse of multiplication, or the opposite. The opposite of multiplication is division. Now, what we're going to use to solve this is something called the division property of equality. The division property of equality tells you that when you divide each side of an equation by the same non-zero number, then the two sides remain equal. Please make sure you have that written in your notes. So how does it look in the equation? Well, I'm looking at 4x equals 28. I see that 4 is multiplied to x. The inverse of multiplication is division. Now we know that fractions are division, or division can look like a fraction. So to show my work on these problems, I'm going to show that I'm going to divide the left side by 4 and the right side by 4. And even in these problems, I want to put these lines down the center. Now, why does this work? Why does the division property of equality work? Well, we know that in yesterday's equations, when you did the inverse of addition and subtraction, your answer turned out to be 0. Because when you add or subtract 0 from a variable, it remains the variable. Adding and subtracting 0 doesn't do anything to a problem. In multiplication and division, it's a little different. When I look at this problem, 4 divided by 4 cancels out, but not because it's 0, but because 4 divided by 4 equals 1. Now, the final thing on the left side is going to be 1x, but when we learned about like terms, we know, or we found out, that when you have a 1 in front of a variable, they don't actually write it. So those 4's cancel out. 4 over 4 is 1, so I'm left with 1x, but we only write x as part of our solution. X equals then whatever 28 divided by 4 is. Now in this case, 28 divided by 4 is something you can do in your head. The answer is 7. It could end up being a large problem or a problem with decimals where you actually have to use long division to try and figure it out. All right, let's try a couple more. Sometimes you're going to be given multiplication equations that look like this. So when you see it written with a time sign in the middle, we know that we can just replace that or rewrite that equation as negative 6b equals 152. It's no different. Now, years of teaching solving equations has shown me that when kids see multiplication equations like this, they oftentimes try to add 6 to each side of the equation. And I get it because they're looking at that negative 6 and thinking it's a minus. But you have to think about the term as a whole. If I add 6, it's not doing anything to the equation. It ends up being negative 6b plus 6. So you have to realize that when you're solving this, that is negative 6 times b. So the inverse of multiplication is division. So I'm going to divide this side by negative 6 because I need to make sure that this cancels out, the negative 6 and the negative 6. and it actually becomes a positive variable. I know that a negative divided by a negative is a positive. When the signs are the same, it's positive. So I am left with 1b, but again, we will only write that as b in our solution. So as of right now, I am at b, and it's a positive b, equals then whatever 152 divided by 6 is. Now, like I said, sometimes you're not going to be able to do this off the top of your head. So I am going to do the long division, 152 divided by 6, to find my answer. Goes 2 times into 15. This is a good review of long division. 15 minus 12 is 3. Bring down the 2. Goes 5 times into 32. Subtract, I get 2 left over. So when I look at what I have, right now I'm looking at 25 whole times with 2 left over out of 6, knowing that I need to reduce if I can. So my final answer here is 25 1/3. Now after all of that work and going up here and writing my 25 1/3, so often we get problems like this wrong because we forget to look back to see if my answer will be positive or negative. So when I'm looking, it's 152 divided by -6. It's actually negative 25 1/3. You have to look back and check. It's actually a good idea when you're writing b equals to write plus or minus or positive or negative right away, even before you solve the problem, to make sure that we're getting these correct. Okay, last example in this type, and then we'll move on. All right, let's look at negative 1 5/10 x equals negative 20 6/10. So this is a multiplication equation. So we know that we need to divide by negative 1 5/10 on both sides of the equation. On the left side, I know that these two cancel out and equal positive 1, because a negative divided by a negative is a positive. So my final answer will be x equals, because that is 1x. I look at the other side of the equation, it's 20 6/10, negative 20 6/10, divided by negative 1 5/10. So like I said in the last example, I'm going to put a plus sign right there, right now, because I know that my answer is going to be positive because I'm doing a negative divided by a negative. All right, let's look at the division. I have 20 6/10 divided by 1.5. I'm going to move the decimal over once, put it straight up in my answer right here. I'm going to divide by 15. 15 goes into 20 one time. That's 15. Subtract, I get 5. 15 goes into 56 3 times. That's 45. Subtract, I get 11. And now I'm moving to the other side of the equals. I'm doing 15 into 110. I know that that is 7. So I'm going to keep going in my problem until it either terminates or forms a pattern. That's 105. When I subtract, I get 5. I'm going to add another 0, bring that down. That's 50. I have 3. That's 45. I subtract, I get 5. And from here, I know that's going to end up being 50, 45, 50, 45. So I see that the 3 is going to repeat in that problem. So I have, as a final answer, 13 73/100 with the 3 repeating. So the next thing we're going to look at is what a division equation looks like. Now we know division in our future is always going to look like a fraction. So in this first example, I want you to notice that if you have something like W over 3 equals -7. That is a division equation because it is W divided by 3. Now, in a division equation, you are going to use the multiplication property of equality. This property states that when you multiply each side of an equation by the same non-zero number, the two sides remain equal. Please write that property in your notes. So if we look at this division equation, W divided by 3 equals -7. The inverse or the opposite of division is multiplication. Now, what I'm going to be multiplying by is 3 because that's the number that's divided. And I always like to write that like this. Okay, now let me explain why this actually works. If I'm going to multiply the left side of this equation by 3, you have to realize that 3 is actually 3 over 1. Okay? And if we're multiplying 3 over 1 times W over 3, we learned that when you're multiplying fractions, you can simplify on the diagonal. So when I simplify on that diagonal, these 3's cancel out, and I'm left with W over 1. The thing is, you don't write something over 1. You don't have to. So what I'm left with is just W. And that will equal what I have left on the other side, -7 times 3. -7 times 3 is -21. And that problem is solved. So we don't show this whole over 1 part of the equation. You don't really need to. It's just this is why it's actually happening when you do the multiplication. So let's try some other examples. Let's say you're given a problem like this. W divided by -1.2 equals 9. Well, first of all, it is a division equation because it has that division sign. I like to rewrite these problems to look like fractions. W divided by -1 and 2/10 equals 9. Now you'll notice I did write the negative with the number instead of in the numerator with the variable. The reason I do that is because I want my variable to end up positive. And because it doesn't matter where you put that negative, it's better to put it with the number so that when we do the inverse here, which is to multiply by -1.2, the negative and the negative cancel out, and you're left with positive W. I'm going to multiply the other side by -1.2, and I'm going to do just like I did in the multiplication equations. I'm going to write what my sign's going to be right away in my answer before I do the math. I have to do 9 times -1.2. Signs are different, so it's going to be negative. Then I'm going to go off to the side, and I'm going to do my work to solve the problem. So 1.2 times 9, or 1 2/10 times 9, that's 18. Carry the 1. 9 times 1 is 9 plus 1 is 10. There is one number after the decimal. So I move it over to the side, and I notice that it's 10 and 8/10, and I already have the negative written into the answer, so I don't need to worry about it. All right, one more example. So it doesn't matter if the variable is on the right side of the equation. What does matter is when you're looking at this problem, the placement of that negative. So we talked about this in the previous example. If you have a negative and it's written here with the fraction bar, you need to decide if it's going to be with the M or if it's going to be with the 11. We want to remember that we're going to rewrite this, or make sure when you write it into your work that you put the negative with the number. So when I'm looking at this, I'm going to rewrite it as -15 equals M divided by -11. Since I'm dividing, the inverse is to multiply by -11. These cancel out, and I'm going to multiply this side by -11. And I'm actually going to end up putting them both in parentheses. So I have m on the right side of the equation this time. I know that a negative times a negative is a positive, so I'm going to write that down right away. And then I will do my work. 15 times 11. 1 times 15 is 15. 1 times 15 is 15. And I get 165. And I know that my answer is positive 165. All right, so we've done multiplication equations and division equations. There is one special case that I would like to talk about. In some situations, you're going to use the multiplicative inverse property. This property tells you that the product of a non-zero number and its reciprocal equals 1. Here's what I mean by that. If I take the number, the fraction 2/3, and I multiply it by its reciprocal, it's going to equal 1. Here's why. Remember, when you multiply fractions, you can simplify on the diagonal. Your diagonal in a reciprocal is always going to cancel out. 3 and 3 cancels to 1. 2 and 2 cancels to 1. So you end up with 1 as the answer. You're going to see fractions within one-step multiplication and division problems. They look like this. I'm going to use that 2/3. So they look like 2/3 x equals 6. Okay, so you're given a number, a fraction, multiplied to a variable. Now, normally when you have multiplication, you use division to solve that. Please don't write this part right now. I just want to show you what happens if you use division. So this is multiplied. If I divide by 2/3 and I divide by 2/3, I know that 2/3 divided by 2/3 cancel out. And then what I have is 6 divided by 2/3. Now, if you recall, when you divide fractions, this is a long division problem right here, so we can see that. When you divide fractions, you take the first number, you change it to multiplication, and then you take the reciprocal of the number you're dividing by. So I took that 2/3 and I took the reciprocal. So I end up doing, instead of 6 divided by 2/3, you end up doing 6 times 3/2. 2 goes into 2 once, 2 goes into 6 3 times. The answer is 9. Okay, so this is why it works, because when you end up dividing by a fraction, division by fractions changes to multiplication, and then you take the reciprocal of what you're dividing by. The multiplicative inverse property is a shortcut for this situation. So let's go back, and now I want you to actually start writing on your notes. Let's go back and look at our original problem. When you have a fraction multiplied to a variable, to get rid of that fraction, what you can do is multiply, use the multiplicative inverse property, and multiply by the reciprocal. Because, on both sides please, because you see what happens when you multiply by the reciprocal, your diagonals cancel out right away, and you are left with x in the problem. So I have x equals, and then on the other side I'm solving 6/1 times 3/2, which is exactly what we solved before. I can simplify. 2 goes into 2 once, 2 goes into 6 3 times, and I end up with 3/1 times 3/1, which is 9. Just like when we showed it as a division problem. Now this is going to be shown a couple different ways, so let's look at another example. So these two examples right here actually mean the exact same thing. We need to realize that in this first example, if you're looking at 2/5 y is actually y/1. So 2/5 y is 2/5 times y/1. If you multiply across, it would say 2y/5, which is exactly what's written in the problem over here. So you have to recognize in both of these situations that you're doing the exact same thing. You have a fraction multiplied to a variable, so you need to use the reciprocal. I'm going to solve it on the second problem because they're solved exactly the same way. So if I have 2/5 y, I'm going to multiply by the reciprocal, which is 5 over 2, and the other side by 5 over 2. The 2's cancel out, the 5's cancel out, and I am left with y. On the other side of the equation, I have 14 over 1 times 5 over 2. I know that 2 goes into 2 once, 2 goes into 14 7 times. So I have 7 times 5 as my multiplication problem, and 7 times 5 is 35. You have to recognize the way that those problems are written and make sure that you use the inverse property to be able to solve them. Okay, you're going to try this out on your own. Good luck. Make sure you ask questions if you have them.